Welcome back to Chapter 14, Analysis and Interpretation. So, before we get into this chapter, since this is toward the end of the semester, just want to kind of clarify, especially with Chapter 14, we're not going to spend a lot of time because I'll kind of go over the brief overview of the chapter, but for the most part, you're not required to truly analyze your data, actually, especially when it comes to this class online. You don't really, when you write your research proposal, you're just doing the proposal part. You're not doing the analysis part of your data. So you're not actually collecting any data and you're not analyzing any data at this point. So just kind of I just want to kind of give a quick overview of what this chapter is about. We won't really go into too detailed. For instance, I mean, the first part of the chapter talk about the inferential statistics. This is kind of how is your data could be inferred to the larger population? Can it be generalized to the population that's out there? So let's say you're doing a study on college student. Can your data truly be representative sample, and your data can actually refer to can be applied to college student all over the world or college student in the US? So can your data do that? So that's what inferential statistics actually referring to. Okay, after you conduct the study, you analyze your data, you evaluate and see whether that data has, kind of going back to your research hypothesis to see whether it's confirmed your hypothesis or it actually opposite to your hypothesis. So when we doing inferential, when we trying to determine whether your data is actually significant or not, we look at your what we call null hypothesis. Your null hypothesis. This is why a couple of weeks ago, when you write your hypothesis statement, I want you to write a null hypothesis as well. So this is meaning that your null hypothesis is referring to there's no differences between the treatment groups or between the variables that you were setting out to see, the independent variables. So those independent variables, there's no significant between one independent variable versus the other, completely the same. So if your data show that there are significant in your independent variables, therefore that means you're rejecting your null hypothesis. You're rejecting that. That means your null hypothesis is wrong. Therefore, your hypothesis is correct. So you are accepting your hypothesis and rejecting your null hypothesis. So the ideal thing is in your research, if we do any research, the ideal is to actually set to reject your null hypothesis and to accept your hypothesis. That's what all of the researchers are aiming for when they set out to do their research, to be able to reject their null and accept their hypothesis. But that's not always the case, and more often time we found the data to be surprising to ourselves, and does not reject the null, which means does accept the null, and therefore you have to reject your hypothesis. But oftentimes we do learn something from those, even though some people consider that as a failure, that your research is a failure because you're not really truly prove what you hypothesized. But that actually very good confirmation, because that actually showed that that there's something, your idea could change, that your hypothesis, your working hypothesis could change, and you have to find a new method, a new way to prove your point. Okay, and a lot of time research kind of accidentally find things or discover things this way by testing it out and find what works, what doesn't work through the research like this. Okay. And you want to make sure there's unbiased as well when you try to infer the stats, making sure your stat is correctly interpreted and correctly analyze as well. Okay, in order to make that inferential. So the key, if you're gonna use for any experimental design, remember we talk about t-test, ANOVA, one-way or two-way ANOVAs, all of those, we look at the p-values. The p-value has to be less than 0.05. Less than 0.05. What does that mean? That means that less than 5% of the population, less than 5% of the time that this occurrence will happen. There's a significant differences between the two variables that you're showing, that you're testing. If you remember from chapter 13, we talk about the bell-shaped curve. With two standard deviation, you actually have 5%. 2.5% on one side, on the right side, and 2.5% on the left side. And this is what the p-value is referring to. That your data is significant because it's actually on the outside group, outside from the norm. If you actually run this test over and over again, it will show that the number will be outside that norm. So 5% will be that 5% group, which is the small group, the significant group that's outside what the normal is. Okay, and that's what we're aiming for when we run the t-test and ANOVA. We want to make sure that your p-value is actually less than 5%, or p is less than or equal to 0.05. When it's less than or equal to 0.05, we reject the null and accept your hypothesis. If it's greater than 0.05, then we accept the null and then we reject your hypothesis. Okay, so it's the opposite. So ideally, when you do any type of research, experimental research, quasi-experiment, or even an actual experiment within subject, between subject, or multifactorial, you want your p to be less than or equal to 0.05. That's what you out to prove. If you actually could prove less than 0.01, that means it's truly significant. That means majority of the time that these two factors is definitely significant. There's one is causing the other. Even at 0.05, definitely there's a significant there. That there's the great significant there. That 95% of the time, you could say that 95% of the time, you confidently could say that these two numbers are different. That these two variables are different 95% of the time. That's what that means. Okay. So let's see. So once you find out your p-value, you should be able to determine whether you could retain or reject your null hypothesis. Okay. And these are the kind of quick summary of all the things, all the experimental that we did, that we talked about, and then what kind of tests should be applied into those ones. So if you have groups between subject, quasi-experiment, versus between or within subjects experiment, this is what you're going to be using. Eventually, you're going to be looking at two tests. Technically, the t-test and also with ANOVA. Those are the two main tests we use. Okay, t-test and ANOVAs. And with correlation, again, we talk about correlation. We use Pearson R or Spearman rule. Pearson R would be this one, and then Spearman rule would be this one. The only time that you use Spearman is when things are in order, ordinal scale. You actually, if you rank from the first person who got the highest score, second person who the second highest, third, fourth, and so on and so forth. When you rank it that way, then you have to use the Spearman rule, which is this one down here, Spearman correlation coefficient. But if you are doing just a plain old correlation, you want to use the Pearson R to test out your plain old correlation. Very easy test to use. Other tests that you could use are these other tests, but for the most part, all of your tests, you should just stick with between those two, the Pearson R and the Spearman rule. Majority of the researcher actually use those two. Okay. Let's see. Looking at this. Okay, the last one we're probably going to talk about is called the chi-square, the goodness of fit test, and chi-square test for independence. So these two tests are looking at the frequency, observing the frequency and combination of what the frequency is to see whether how often things occur, and we'll see whether there's a relationship between those frequency. Okay, then that's what we use. And in any type of research, you might want to keep in mind the numbers too as well, the number size, the sample size. Like I think I mentioned before, that you want to have big enough sample size in order to test out the population. Let's say if you really want to test out for drugs, for big medication drugs that actually affect the whole U.S. population, you need at least 1,000 to 2,000 people study to actually test out your medication, and those are usually in the trial, the third stage trial, to see whether how drug affects the mass population. The smaller group would be, if you want to do a small size sample, I would recommend at least 30 people to actually see any significant in terms of your studies. Okay. And we talked about Cohen's before. Kronberg actually, and this is Cohen. This is the effective size of how you want to make sure that the size of the population is accurately represent. You could use this test to see that as well. Okay, and then you could use the ETA squared to see the variance to analyze the data on the ANOVA. But again, for this class, you don't have to worry about these. Okay, because we won't be using any of these in our studies. Okay. That's kind of conclude of what chapter 14 is about. Thank you for watching, and I'll see you on the next one, the last one, chapter 15.